Oh boy, it's geology round 2. So hopefully you guys watched my video that showed just how ridiculously old the Earth is. It's really hard to wrap your head around how long the Precambrian era is based on something that looks like this, because it kind of makes it seem like it's the same length of time. But it's not. It's like 90% of the Earth's time was in the Precambrian era, with really not a lot of anything occurring. In fact, the stuff that we think of as being very cool really didn't start to occur, like dinosaurs, up until this point. They had a great big long run. They died out. Then we had all the megafauna, the crazy stuff we'll talk about a little bit later. The megafauna means giant mammals and birds and things like that. And then we have humans, and the tiny sliver up here that takes up less than a fraction of a percentage of time on Earth. Okay, so let's talk a little bit about something that relates to Canada. That Precambrian era, happened 4.5, 4.6. Remember, we're not exactly sure within a million years or so, or even plus or minus a little bit, how old the Earth is. It's got to be at least that old. Up until 590 million years ago. So that Precambrian time is a huge, huge length of time that the Earth has been around. And there's a massive section of Canada that has rock from that time zone. And it's the Canadian Shield. We don't have any of that rock in Alberta, but once you hit Ontario and Quebec, that's when you have this rock called the Shield. It's actually, that whole area of Canada is actually called the Shield. So it's really tough to basically drill in Quebec and Ontario. Quebec and Ontario doesn't have any gas or oil like Alberta and Saskatchewan and BC do, because this rock is like impenetrable. It doesn't allow gas to like bubble up to the surface. It's really, really rocky. Quebec is super, super rocky. Types of rock that we spend thousands of dollars on for our driveways, like this crushed kind of sparkle rock, they basically pave their highways with it because they have so much of it. So they have so much of this different type of really, 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 really tough rock. So evidence that this is around of the Precambrian era in Canada is this ancient rock called the Shield. Okay, so remember that for the Google form you guys are going to be doing. The Precambrian Shield makes up most of Canada's land mass, more than half. So more than half of Canada's land weight comes from this super dense rock, and that's including the freaking Rocky Mountains. Think about that this rock outweighs all of the mountains in BC and Alberta. And we've been able to study them because as erosion takes away the dirt, we see the rock beneath outcrops. And later in this unit, we're going to talk about radiometric dating, which uses isotopes, radioactive isotopes, and how long it takes them to lose basically their mojo, which is called radiation. And we can radioactive date the rocks to figure out how old they are. And they're ancient. They're the oldest rocks in Canada. Okay, now before we get to how did it get there and why is that a thing, we need to talk about what the Earth is made of. And the Earth is made of a bunch of different layers, like an onion, but some layers are way thicker than the other and some layers are gooier. We're going to be using the acronym CLAM, and that's going to go through the 4 different layers, and then we're going to talk about the core. So the acronym I'm going to be using is called CLAM core, and it's basically the 6 different layers of the Earth. There's way more to it than this, but we're just going to talk about those. You start with the crust, where we live. Humans live on the crust. Directly under the crust, you have this rocky layer called the lithosphere. Then we have the plasticky, gooey layer called the asthenosphere, and that's what the giant plates of the Earth kind of float on. Underneath that, the biggest layer of the Earth is the mesosphere, and here you find the radioactive elements trapped deep, 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 deep underneath the Earth's crust. And then at the center, we have a liquid outer core, and then we have a solid core inside the Earth, which gives Earth a magnetic field, plus the spinning liquid core as well. Okay, so let's just break down the four main parts. The crust is rocky. It's very thin. So super, super, super thin. And this is all we know. Our ability to drill, like the deepest wells ever drilled on Earth, have not even got to the lithosphere. And if they have, they've just kind of like touched it. That's how thick the Earth is and how hard it is to drill down. Now, how do we know what different layers of the Earth is made of? There's some pretty advanced science that goes into that. Seismology basically is how fast sound waves move through different materials. So they can say on above ground, it moves this fast. And when they run it through the Earth, it moves that same speed. So it has to be the same medium. Okay, the lithosphere is a rocky layer. Okay, the asthenosphere is plastic. It's a semi-liquid. And the Great Plates I should say the lithosphere makes up the tectonic plates. And the tectonic plates are these massive slabs of rock that move very, very, very slowly because of the ebb and flow of the liquid asthenosphere. That gets into the rock cycle, and that's really exciting. We'll talk about that probably next week. Then we have the mesosphere, which is a very thick layer of mostly solid rock. You have radioactive elements here. If we could ever get to this layer, we would have an unlimited amount of nuclear fuel. It's just so beyond our technology to get there because we basically live on the eggshell of an egg, and the most our drills have been able to do is get through a fraction of the eggshell. It's really hard to wrap your head around, but it's true. The outer core is a liquid core, and the inner core is a solid core. Both of these cores give us a magnetic field. Not all planets have a magnetic field. That magnetic field at the center of the Earth and the molten core gives us a protective field around the Earth. So rays from the sun that are potentially dangerous bounce off. And they are brought to the poles. Okay, this is very hard to imagine because this is flat, but remember you have to think this is 3D. And that's where the northern lights come from, is the bouncing off the rays, basically, from the sun. Now, if we didn't have the magnetic field, those would bombard the Earth. Who knows if life would even be around with those dangerous rays hitting the Earth. That's the problem with sending humans to Mars, is Mars does not have a magnetic field. So, and same thing with the surface of the moon. The astronauts are at hugely elevated risks of cancer from very high energy waves like X-rays and gamma rays and even UV rays bombarding them way more than Earth. Okay, so here's a good example of how ridiculously thick some of the layers are. So humans live on the crust, and Then the lithosphere is the next. Now, some of our drills have got maybe to the top, but we don't have holes straight down that are 100 kilometers. So the lithosphere runs down 100 kilometers. Then from the 100 kilometers deep to 700 kilometers, you have the asthenosphere, and that's that liquidy stage. Then we have the mesosphere, and that's that biggest part of the Earth. Like, it's insane. Like, imagine, it's so hard to imagine 20,000 kilometers of pure rock. Like, think about just driving from here to Edmonton. That's what, 200 kilometers maybe? Times that by, not 10, but times that by 100. 100 times further of pure rock. That's insane. Then we have the liquid, and then we have the rigid, solid core. And the cool thing about the core is it's made of iron and nickel with a little bit sulfur. So it's a really neat core. Like, if we could ever get to it, I don't know why you'd want to steal metal from the core, but we would have an infinite supply of iron and nickel, pure iron and nickel. Okay, all right, so let's recap. See if this is going to work with my circles. Here we go. Let's see. So we got this guy. Move that a bit. Uh-oh. I don't know if this is going to work because... There we go. Okay, so I'll make that a little bit bigger. Perfect. Okay, what's the outer layer called? It's called the crust. Remember our acronym, CLAM. Then we have the next layer. Okay, there's the next layer. Probably made the circle a bit too big. That's fine. Lithosphere. Then we have the next layer, which is, make it a little bit bigger. There we go. Asthenosphere. Then we have the massive, huge, what's the next one called? Mesosphere or mesosphere. Okay, so I'm going to make this one really chunky. That's the M in clam. Mesosphere. And then we have the two cores. Okay. And I only need to put one circle because the outside is liquid, inside is solid. Okay. That is the parts of the Earth. Okay, we're going to talk about the rock cycle next lesson. I've got a video about a really deep hole that was drilled that's in the plan today, and I have a Google form that is going to be for marks. Okay, so some of the Google forms is just to see if you're doing well. There's a 6-question Google form about this that is going to be for marks on Power School. So make sure you do it, please. Awesome. Thanks, guys.